Hi, in this video we're going to learn about the intuition behind the probability density function, or the PDF. So let me draw out a graph real quick. Okay, this graph represents the PDF function, and this function is a Gaussian function. So on the y-axis, it's the PDF f of x with respect to a variable x. And this variable could represent anything. For example, it could represent position. And since this is Gaussian, it is symmetric with respect to x1 here. So the intuition behind what a probability density function is that it's the probability per unit x. And what I mean by that is every point here is not the actual probability. It's only a probability density, which is what is described by this. This is the most important concept. For example, this point all the way up here could be 5, but we know that probability can only be up to 1, so 0 or 100%, or 0 or 1. But how can this equal 5? The reason this could equal 5 is because this does not actually represent a probability. This only represents a probability density. So if we would want to get the probability, what we have to do is integrate, because we know that once we integrate, we get the probability, since this is the slope of the probability with respect to x. So we know that we have to integrate dp dx with respect to x to get the probability function. So for example, if we integrate from this point up to this point, let's say that this is x naught and this is x2, and we integrate this entire portion, this portion will be a probability, let's say x naught 2. And we know that this probability has to be less than 1, because if we integrate the entire function from negative infinity to infinity, we know that this must equal 1. Many things in nature are described by a probability density function, and one example, and one of the most famous examples, is the probability wave function. So this represents the probability density of where a particle will be with respect to a position x. So this is exactly the same graph, except we would just replace this by a new symbol of this. And this shows up in quantum mechanics, since in quantum mechanics, particles are not just at one location. There is a probability density of where a particle could be. So in this case, if this were the graph that describes the PDF of this probability wave function, then if we integrate from x0 to x2, we get the probability of the particle appearing between these two intervals. I hope this video helps. Thank you.